Hello everybody, Kelvin here. In today's video we're going to be taking a look at NATing between the ASAs on two different sites, and we're going to be changing the IP address of two, let's say, servers so that they can be reached by a specific public IP address. So it's pretty much one-to-one NAT, static NAT. What you're looking at here is if we just take a look at the topology here, we can see that, let's say for instance, this is site 1 and it's got two ASAs, an active and a standby pair, which we'll take a quick look at after. And we also have some items in the DMZ such as ICE. The Windows 7 Lab 1 is going to be acting as our first server. Moving across to the right, we then have, let's say for instance, this is our branch site with our second server. And we also have this sat behind an ASA as well. So all the NATing is going to take place on the ASA. We have a live internet feed going out to my internet, and we also have what you could call a simulated WAN link. So for instance, I've set the configurations up so that any traffic that is not in the routing table will be pushed out to the internet, and everything else that is destined for either sites will be sent across a WAN link. So we'll take a quick look at the configurations that I've done before we actually start trying to configure basically connectivity for each of these two servers. Then what we can do is we can take a look at the Wireshark, so we could take a look at the packet capture. And we'll be able to see then the source and destination, which should be changed. So if we move over to the right here, what we're looking at here is router 1. So this is, let's zoom back out and take a look here. So on the topology, router 1 is here, so it's on site 1, let's say for instance ISP, and respectively we have router 2 there at the bottom. So the configurations, as you can see there, we've got a default route that's going out to what's going to be my internet, and then we can see that we've got OSPF configured between the two, let's say for instance ISP routers, and that's sharing, so we can see that the networks are connected to either side, and we can see that, I've got some, but most networks are using /29 subnetted. So at present we can see on this Lab 1 PC, this is on the left side, let's say the main site. It's showing that we've got an active internet connection, but that's only because I've got, if I do show access list, we can see that I've got a DNS rule, which is why that's working. But if we try and go to or browse anything on the internet, it's not going to let us. If it lets me type it in, yeah, there we go. So it's not letting us, it's telling us that we haven't got no internet connection. So we could fix that after, but our main what I wanted to show today was that I wanted to create this static one-to-one mapping between both sites on this topology, so that we've got communication on specific IP addresses. So on the ASA on the left, on the main site, let's say, we don't need to deal with the second one because that's in standby, so all configurations are replicated. So if we just do a show failover state. So we can see that the configuration shows that our state is primary active and the standby is ready. So if I just do a show failover, we can see that this is the primary one and it's been active for quite a while, and you've also then got your secondary, which is active as well. So if we look at NAT, I don't think I have any NAT configured. No, I don't. So we have NAT configured at the moment. So let's see if this can get to, let's just flick this over here so we can see the topology. So let's try and ping to 209.165.100.9, which is router 2's interface connecting to branch 2's ASA. And this is going to fail, and the reason being is we don't have an access list configured on this ASA. So we'll move back down to here, and what we'll do is we'll configure an access list now to permit this traffic. So if we just do a show access list, the other list that we've got configured is that of the DNS, nothing else. So we'll configure this rule now, so we can, before we do that, what we'll do is we'll create a we'll create some objects that we're going to need. So let's create an object for the Windows 7 Lab PC. So we'll say object object network, and we'll call this one host, or let's call it main site host, and the IP address is 192.168.10.10. and what we'll do is we'll add an access list that inside permit ICMP to any we'll say from main site host to any destination, and then we'll try this ping again now. Show access list, and you can see now that we've got hits against this access list here, but if we then look back on the lab computer, we can see that it's not working, and the reason being is because it's not being natted. So if we go back into that object, sorry, doing that wrong way around, object network. If we go back into this now, and we just do a NAT inside, outside, and we'll do dynamic interface, which is essentially PAT, and we try again, we can see now that we can actually ping router 2's interface, which is connecting to ASA2. So let's try and ping now the ASA2 interface. Now you can see now that we can ping that as well. Okay, but if we try to get beyond that and we try to ping the internal PC or server, let's call it, which is 192.168.20.10, this isn't going to allow us to do that. We need some form of NATing and access lists on that ASA as well. So what I'm going to do, because we're not going to need this NAT, I just wanted to show you that, is I'm going to remove that NAT off that object, because we'll come back to, we're gonna come back, but we're going to put a different IP address against that host. So what we'll do is we have a /29 on the outside let's say interface of the ASA. So we're using .1 and .2 for the active and standby ASA, and we're using .3 for the routers interface. So what we can do is we can use .4 for the public IP address for this one-to-one mapping. So what we'll do is we'll create another object network, and we'll call this main site host NAT. And this is going to be 209.165.100.4. Move that extra 2 there. Okay, so now we've got that. And what we'll also do is we're going to need this later on, because what we're going to do is I'm going to create an object for the public IP address which hasn't been created yet for the ASA2, because we're going to be also changing the IP address for not only from the source, but we're going to be changing the destination as well, and we're going to do this via objects as well. So object network, and we'll call this one branch public IP or pub IP, and let's give this a public IP of 209.165.100.10 is the ASA, so we'll give it 11. Okay, so now that we've got our objects created, we need to go back into, let's just do a show run object, and main site host. So we're going to go into this object, and we're going to assign a static IP address of public IP address of this object. So to do that, we jump into the object network, which I'm in, and we'll do NAT inside. I'm using sub interfaces, which is why it says inside 1, 2 outside, and we're going to do static, and we can see there that we can use a word for the mapped object group. So we're going to use this object group here. So there we go, and we'll enter that. So if we do a show NAT now, we can see that we've got that NAT rule in place. However, it's got no hits because we're not trying to use it, and we also don't have any access list in place. So what we'll do now is we'll create an access list or 2. Let me just do show access, thinking on iOS, show access list. So we've got the ICMP from inside to any. So what we'll do is we'll create an outside access list that permits anything coming to the public IP address of 209.165.100.4, which will get translated to the Windows 7 Lab 1 server. So what we'll do is, before we do that, in fact, let's jump over to this PC, and if we try and ping 192.168 10.10, it's not going to work. That's because we're going to need to do pretty much the same on this side for the device behind the ASA on the branch site in order for it to work. So if we try and ping 209.165.100.17, let's say, which is root 1 serial interface, it's not going to work again because we need to have the correct permissions in place. Okay, so we'll finish off now by doing the access list for outside. Access list outside permit, and we're going to do permit ICMP. We're going to do object, which is going to be the public IP address of the Windows 7 Lab 2, which is what we're mapping it to. So we're going to do, let me just press enter, I can't remember what I called it, show run object. So it's going to be this one. If we just up arrow, and we'll use this object, branch public IP, and it's going to be going to the main site host, which is this one, not the NAT address because it'll be getting translated. So you specify the real IP address, so we'll do object, and that's it. And then we'll do access group outside in interface outside. So if we do a show access list or show run access list, we can see now that we've got the inside ICMP rule that allows us to ping from the Windows 7 Lab 1 server to any destination, and we also have the outside ACL that allows us to ping from the branch public IP address, which is what the Windows 7 Lab 2 PC will be translated to, and that's allowed to ping directly to the main site's host. Okay, so that's that rule done. Again, at the minute it's not going to work because we need to do this second ASA. So what we'll do is we can do, I'll just do a show run object. Yep, so we've got no object. So again, we'll do the same thing. So object network, and we'll call this branch host, and host 192.168.20.10. We'll do object network branch pub IP or branch host public IP, and we'll give this one, we said we're going to use 209.165.100.11. And then last but not least, we'll do object network. We'll specify the real, we'll create an object for the lab 1. So we'll call this one main site host, and that is 192.168. In fact, yeah, we could put that in, but we're going to need the public address in fact, so we'll do 192.168.10.10, and we'll do main site host pub IP, and we'll do 209.165.100.4 we said it was. And this is so basically both devices, both servers can communicate with each other on these public IP addresses only. So we'll do that, show run access list. Got no access list in place. So if I do access list inside permit ICMP from object, what did we call the object branch host, go into object this public IP address of the main site. So I'm going to do access group inside in interface inside one. Oh no, it's only inside on that one. Show access list. So we've got that access list there. So basically, as we can see here, we now have the lab 2 server 192.168.20.10 pointing to 209.165.100.4, which is the public IP address for Windows 7 lab 1 server. So in fact, if we try and ping that now, we should actually be able to ping not the private address. So if we try to ping the private address, it's not going to work, so we'll try that though. So ping 192.168.10.10. You can see that it's not going to work, but if we ping the public IP address that we assigned, which is 209.165.100.4, oops, it's not going to work because I haven't done the NAT yet, because show run object, I haven't put the NAT on the object. So what I'll do now, is I'll put the NAT on the branch host. So and we'll do NAT inside, outside, static, and it's going to be branch host public IP. There we go. Oh wait a minute, but it's because I haven't done it right. There we go. Public IP. Show NAT. Okay. Now if we try it again, we can see now that we can successfully ping. And if we do show NAT again, we can see that we've got 4 translated hits, which is from the 4 pings that we've just sent. And also if we do show access list, we can see as well that we have 8 hits with the return traffic for the ICMP. So that's for inside. Now we know that we can communicate, so site 2 or server 2 can now communicate with Windows 7 lab 1 on that public IP address. But if we try and ping the public IP address of server 2 from server 1, which is at 11, it's not going to work. And the reason being is, even though we have the access list here on the inside, that's for the communication from site 2 to site 1, even though we've got the, where's the ICMP? We'll just do a show run access list and it's a bit clearer. So in here we can see that we can ping outside to any, but we don't have the on this router, and we've got the outside, which allows access from lab 2 to lab 1 server. So we need to do the same now on the second ASA, because if we do show run access list, we only have the inside permitting, so anything that's trying to come in from the outside is going to be denied. So we'll do access list outside, permit ICMP, and we're going to use object. So scroll up and find these objects. So we're going to use the public IP address, which is this. And we're going to allow it to communicate with branch host, real IP address. And now we'll do an access group outside, in, interface, outside. Let's just do a show run access list. And now you can see that we've got 2 access lists now. However, the outside won't have any hits yet, as we can see here, because we've not sent any traffic. But now if we try, we can now ping. We which is great. So we've got both servers now communicating, talking to each other on two separate public IP addresses dedicated to them. And if we do a show access list again, we can now see that it's got hits. And if we do a show NAT, we can also see the same. Okay, so what we'll do now is I've got two captures going. I'm just going to take this over here, bring these forward. So I've got two captures going. This is on switch 3. So this is capturing this interface. The top one's capturing switch 3's interface, which is connected to the branch ASA 2. And then we've got the second capture, which is capturing from the IOU 1 through to the ASA. And what we're going to do is we're going to take a look when we send the echo request. We're going to see what addresses are actually shown on here. So we'll start by sending a ping from the Lab 2 server to ASA 1. And what we'll do is we'll just quickly have a look at both. So we'll have a look at the switches, switch 3's interface, which should show the actual real IP address. Then we'll flick over to this one, which should show the public IP address only. So then the host on the other side will never know the real IP address. So if we just do this ping now, we can see these pings come in here. So I'll just hold that there and there. So what we can see here is that source 192.168.20.10, which is what's expected from this host, is pinging 209.165.100.4. So likewise, it's only going to know, it's not going to know Lab 1's real IP address. It's going to ping the public IP address, which is dedicated 209.165.100.4, which is dedicated to Lab 1 server. And you can see that we also get the response back from 100.4. So even though the response is coming back from, you know, the Lab 1 real IP address of 192.168.10.10, we're only seeing the translated address here, so we never see the real address. Now if we flick over to the other side, we can see now that the source of the ICMP request, ping request, is from 209.165.100.11. So we can see that the source on the inside can show us because it's on, you know, it's behind the actual network before it gets natted. However, after it's been natted, we can see that on the other side only sees 209.165.100.11. Okay, in the destination we now see the real IP address of Lab 1 server. So we can see that this is how, you know, NAT works. This is a concept of NAT, and what we've basically done here is we have translated two separate addresses on two different sites to two different public IP addresses, and allow communication via those two devices. So that's it pretty much from me. The reason I wanted to kind of do this video is because you know, NAT can be quite confusing to some people, and you know, especially when you're trying to get your head around it, and you know, it's always better to put things into perspective, you know, by showing you the packet captures and showing you the configurations on the ASA in terms of how you can actually you know, get these, you know, get devices talking via public addresses. So yeah, I hope you found that useful. Any questions, feel free to reach out to me, and yeah, just look out for more upcoming videos soon. Thanks for watching.